According to the National Electrical Code, an NM cable is not permitted to be run inside conduit, including sleeves. NEC 334.10b states that an NM cable shall not be installed in raceways except as permitted in 300.22c. NEC 300.22c only allows an NM cable to be installed in raceways when the raceway is protected from physical damage and has an internal diameter not less than the outside diameter of the NM cable. In this case, the sleeve is considered a raceway, and it is not protected from physical damage since it is exposed to the elements. Therefore, running an NM cable inside the sleeve and then into the conduit is not permitted by the NEC. If you need to run wiring from the house to an external light fixture, there are several alternatives to NM cable that are permitted by the NEC. Firstly, UF cable is a direct burial cable that can be installed underground or in conduit. Secondly, THHN or THWN wire. These types of wire are intended for installation in conduit. They must be used with the appropriate conduit fittings and connectors. Thirdly, BX cable. BX cable is an armored cable that can be installed in conduit or directly exposed. It is important to use the correct type of wiring and installation methods to ensure the safety and proper operation of your electrical system. If you are unsure about the code requirements, it is always best to consult with a qualified electrician. Let's delve deeper into the specifics of why NM cable is restricted from conduit and explore the acceptable alternatives in greater detail. The National Electrical Code, or NEC, is the cornerstone of electrical safety in the United States, setting the standards for safe electrical installations. One of its core principles is ensuring that wiring methods are appropriate for their intended environment and application. NM cable, or non-metallic sheet cable, is commonly used for interior wiring in dry locations. Its construction consists of insulated conductors wrapped in a non-metallic outer jacket. This jacket provides a degree of protection, but it's not designed to withstand the harsh conditions that can be encountered in conduit, especially when exposed to the elements. Conduit, on the other hand, is a raceway designed to protect wiring from physical damage, moisture, and other environmental factors. It's typically made of metal or rigid non-metallic materials like PVC. While conduit provides excellent protection, it also creates an enclosed space where moisture can accumulate. This is where the incompatibility with NM cable arises. NM cable's outer jacket is not waterproof, and if moisture accumulates inside the conduit, it can degrade the cable's insulation, leading to potential electrical hazards such as short circuits, ground faults, and even fires. Moreover, the NEC explicitly prohibits the installation of NM cable in raceways, with limited exceptions. Section 334.10b of the NEC clearly states this restriction. The exception mentioned, 300.22c, pertains to specific applications in darks, plenums, and other spaces used for environmental air. These spaces have specific requirements for wiring methods to minimize fire hazards and ensure air quality. Simply running NM cable through a sleeve or conduit to an outdoor light fixture does not fall under this exception. The sleeve in this scenario is considered a raceway and is not protected from physical damage or the ingress of moisture. Therefore, installing NM cable in this manner violates the NEC. Now, let's explore the code-compliant alternatives that can be used to safely run wiring to an external light fixture. The first alternative is UF cable, or underground feeder cable. UF cable is specifically designed for direct burial in the earth and for use in wet locations. Its construction features individually insulated conductors embedded in a solid thermoplastic material, providing excellent moisture resistance and physical protection. UF cable can be installed directly underground without conduit, or it can be run inside conduit for added protection, especially in areas where it might be subject to physical damage. When using UF cable in conduit, ensure that the conduit is properly sealed to prevent moisture from entering. The second alternative involves using individual conductors like THHN or THWN wire inside conduit. THHN and THWN are single conductor wires with thermoplastic insulation and a nylon jacket. THHN is suitable for dry and damp locations, while THWN is suitable for wet locations. These wires are designed to be installed inside conduit, providing a complete wiring system that is protected from physical damage and environmental factors. When using THHN or THWN wire, it's crucial to select the appropriate conduit type and size based on the number and gauge of conductors. Common conduit types include EMT electrical metallic tubing, PVC polyvinyl chloride, and rigid metal conduit. Each type has its own advantages and disadvantages in terms of cost, ease of installation, and resistance to corrosion. You'll also need to use the correct fittings and connectors to ensure a secure and watertight connection between the conduit and the junction boxes or enclosures. The third alternative is BX cable, or armored cable. BX cable consists of individually insulated conductors wrapped in a flexible metal sheath. The sheath provides excellent physical protection for the conductors, making BX cable suitable for both exposed and concealed installations. BX cable can be installed directly without conduit in many applications, but it can also be run inside conduit for added protection, particularly in areas where it might be subject to severe physical damage. When using BX cable, it's important to use the correct fittings and connectors to ensure a secure and reliable connection. Also, be aware that BX cable requires proper grounding to ensure electrical safety. Regardless of the wiring method you choose, it's essential to follow all applicable codes and regulations. This includes proper sizing of conductors, selecting the correct overcurrent protection circuit breakers or fuses, and ensuring proper grounding. Overcurrent protection is crucial to prevent overloading the circuit, which can lead to overheating and fires. The size of the circuit breaker or fuse should be matched to the ampacity of the conductors. Grounding provides a safe path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. In addition to the NEC local codes and ordinances may impose additional requirements for electrical installations. It's always a good idea to check with your local building department to ensure that you're complying with all applicable regulations. If you're not comfortable working with electricity or if you're unsure about any aspect of the electrical installation, it's always best to consult with a qualified electrician. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes. They can also help you select the best wiring method and materials for your specific application. Remember, electrical safety is paramount. Improperly installed wiring can pose serious hazards to yourself, your family, and your property. By following the NEC and consulting with a qualified electrician when needed, you can ensure that your electrical system is safe, reliable, and code compliant. Now let's consider some additional factors that can influence the choice of wiring method for an external light fixture. One factor is the distance between the house and the light fixture. For long runs, UF cable may be a more economical choice than running individual conductors and conduit, as it eliminates the need to purchase and install a significant amount of conduit. However, for short runs, the cost difference may be negligible. Another factor is the aesthetic appearance of the installation. If you want a clean and unobtrusive look, running wiring in conduit may be the best option, as it can be concealed behind walls or landscaping. UF cable, on the other hand, is typically buried directly in the ground, which may not be suitable for all landscaping designs. The type of soil in your area can also influence the choice of wiring method. In areas with highly corrosive soil, it's important to use conduit and fittings that are resistant to corrosion. PVC conduit is a good choice for corrosive environments, as it is not affected by rust or oxidation. Metal conduit, on the other hand, may require special coatings or treatments to prevent corrosion. The climate in your area is another important consideration. In areas with extreme temperatures, it's important to use wiring and conduit that are rated for those temperatures. THHN and THWN wire are available in various temperature ratings, and PVC conduit is also available in different grades that are suitable for different temperature ranges. The type of light fixture you're installing can also affect the choice of wiring method. Some light fixtures require specific types of wiring or connections. For example, some fixtures may require a dedicated grounding conductor, while others may require a specific voltage or amperage rating. Before starting any electrical work, it's essential to disconnect the power to the circuit you'll be working on. This can be done by turning off the circuit breaker that supplies power to the circuit. Always double check to make sure the power is off by using a voltage tester. Never work on live electrical circuits, as this can result in serious injury or death. When working with wiring, it's important to use the correct tools and techniques. Use wire strippers to remove the insulation from the conductors without damaging the wire itself. Use wire connectors to make secure and reliable connections between wires. Never twist wires together and cover them with electrical tape, as this is not a safe or code-compliant method of making connections. When installing conduit, it's important to follow the manufacturer's instructions carefully. Use the correct tools to cut and bend the conduit. Use conduit fittings to make secure and watertight connections between sections of conduit. When burying a UF cable, it's important to bury it at the proper depth. The NEC specifies minimum burial depths for UF cable based on the voltage of the circuit and the type of location. In general, UF cable should be buried at least 12 inches deep in residential areas and 18 inches deep in commercial areas. When backfilling the trench, be careful not to damage the cable. Use a shovel to gently backfill the trench with soil, and avoid using heavy equipment that could crush the cable. After completing the electrical installation, it's important to test the circuit to ensure that it's working properly. Use a multimeter to check the voltage and amperage of the circuit. Use a ground fault circuit interrupter or GFCI tester to ensure that the GFCI protection is working properly. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas to protect against electrical shock hazards. If you encounter any problems during the electrical installation, it's important to stop and consult with a qualified electrician. Don't try to fix the problem yourself if you are not comfortable working with electricity. Electrical work can be dangerous, and it's always best to err on the side of caution. By following these guidelines, you can ensure that your electrical installation is safe, reliable, and code compliant. Remember, electrical safety is everyone's responsibility. By taking the time to learn about electrical codes and best practices, you can help to prevent electrical accidents and protect yourself and your family from harm.